All right, so when we left off, we were talking about array. We explored what array looked like, and it's just basically an endpoint and then an arrow going in some direction. Okay, and it goes forever in only one direction. So here's the technical definition for array. Array is a part of a line that consists of an endpoint and all the points on one side of that endpoint. And it doesn't matter which side it is, whether it's the left, the right, the up, down, diagonal. It doesn't matter. Array can go in any different direction. Okay, but the key idea is that it has one endpoint and it goes forever in one direction. Now, another vocabulary term that I want you to know is the idea of opposite rays. So let's take a look at that. Opposite rays are collinear rays with the same endpoint. They form a line. Okay, so that definition is not too terribly clear. We'll talk about what that word collinear means in just a second, but I imagine you know what an opposite ray is, or what two opposite rays are, just by looking at it. So let's go ahead and get a visual on this. So here we have a line with a bunch of points on it. Matter of fact, that's what that word collinear means. It means on the same line. So here we have a bunch of points that are collinear. So opposite rays are two rays that share the same endpoint. So I'll pick point G right here. And I'll make a ray. Oh, let's make that line thicker. Going one way. Now I can call this ray GH, ray GI, ray GE, GJ. It doesn't really matter, as long as you always start with the endpoint, which in this case is G, and then you pick one of the letters that's on that side of the ray. And then I'll go ahead and pick a different color, and I'll do a different ray, an opposite ray. So I pick the same endpoint, and I go the exact opposite direction. So ray GF or ray GD. Both are good names for the exact same ray. So I can say that ray GF and ray GH are opposite rays. So if you've got two rays that have the same endpoint and they go opposite directions, then what's happening there is two opposite rays will make a straight line. All right? It's good that you know that. Okay, back to our vocabulary. We talked about this word collinear, and it means together on the same line. Let's go ahead and break this word down so that it makes sense. It's not just a random vocabulary word. If you take a look at the first two letters, that prefix is co. Co means together. So a co-worker is someone who you work with. If you cooperate, you get along, you work together with each other. Also in that word is the word line, L-I-N-E. The word linear is an adjective used to describe a line, but the word line is also in there. So collinear means together on the same line. All right, so very important word to know. It only takes 2 points to determine where the line goes, but you can have an infinite number of points on that line. And all those points are collinear. Next vocabulary word I want you to know is segment. So a line goes forever in both directions. A segment has an endpoint and will go forever in one direction. But what happens if you have a flat path that has a definite start and a definite stop point? That's a segment. So if I've got 3 points here, I've got point A, B, and C. If I connect them, but instead of making the line go forever, if I start at A and then stop at C, that's segment AC. It's not line AC because it definitely starts and stops. So we call that segment AC. So much like with the line in the ray, you put the two letters and then the line on top. Okay? If I were to connect segment A, or point A to point B, that would be segment AB. Or you could call it BA. If you switch the letters around, it doesn't matter. That one endpoint doesn't have to always be first. So the red one could be segment CA. Doesn't make a difference. However, make sure that when you're doing this, you only use 2 letters. So for instance, if I have that segment right there, I would call that segment RT. Now the fact that S is on that segment does not change the name of that. You always go with the endpoints. So RT, that's a good way of labeling that. Some people I see do this. And that's a no-no. You don't want to do that. When you label a segment or a line or array, you only use 2 letters. Never use 3 letters to represent a line, a segment, or array. There's other things that are represented by 3 letters, but a line, a segment, and array is not one of those. All right, let's go ahead and wrap this up. Let's get to our last concept here. We've talked about points. We've talked about lines and different variations of lines like segments and arrays. So let's get to our last concept, which is the idea of a plane. All right, a line is a one-dimensional thing. It can only go one way. A plane is a two-dimensional thing. Let's take a look at the definition here. In Euclidean geometry, a plane is undefined. Fantastic. You can think of a plane as a flat surface that extends forever and has no thickness. So we see planes all the time in real life. A desk, a table, the ceiling, the floor, walls, those are all examples of planes, just flat surfaces. Now, in the purpose of geometry, a plane goes forever in each direction, okay? So walls definitely have definite start and stop points. Tables definitely have definite start-stop points. But the plane that they create, in theory, goes on forever. So just a little point to note on that. So here we have a visual example of a plane. It's kind of hard to show a flat surface that goes on forever in both directions. So what we do is we kind of make a little parallelogram there, and that looks like a two-dimensional drawing of a plane. So here you see within this plane it has 2 lines in it. It's got several points in it. We learned the word collinear means together on the same line. Another word that you need to know is coplanar, which means on the same plane. So all these points are coplanar, and both of these lines are coplanar. They're all in the same plane. Okay? Now, how many points does it take to determine a plane? And think about this. How many points does it take to get something to balance? So for instance, if I have a tripod and I have all 3 legs together and I set it down, is it able to balance on its own? No. If I were to have it on 2 legs, would it be able to balance on its own? No, it'd probably fall one way or the other. But if I take the tripod and I spread all 3 legs out, it hits 3 different points on the ground, and it's able to stabilize. Okay? So that's proof right there that it takes 3 points in order to establish a plane. So anytime you're naming a plane, you're going to use 3 points to name it. So for instance, this plane right here, I could call it ABD. And there's no fancy symbol or line across the top or anything. If you see 3 letters together, you automatically assume that we're talking about a plane. I could call it plane CFE. I could call it lots of different ways that I could name it. There's 6 points there, so like 120 different ways that we could name this plane. However, there's something that you need to know. I cannot call it plane ABE. The reason I can't call it plane ABE is because A and B and E, they're all on the same line. So if you have 3 points that are on the same line, you could take that plane that's in there and you could spin it around that line and it would be different planes. So when you make your name for your plane, make sure you pick 3 points that are non-collinear. Okay, so ABE, no good. DCB, Those points are all in the same line, so I cannot use those 3 points to name the plane. All right? So I told you with 6 points on it, there's 120 different ways to name it. And sometimes when you get a lot of points like that, it can be real confusing about which plane you're talking about. So there is an alternative way of naming a plane, and that's using a capital cursive letter. So if I wanted to call this plane R, I could put that R in there, and all of a sudden I say plane R, you know exactly what plane I'm talking about. So this is especially handy when you're more focused on the planes themselves as opposed to the actual points. So here in this example, this front plane, I could call that plane A. This side plane, I could call that plane B. And this top plane, I can call that plane C. Okay, if I had to have points all over this in order to name it, it can get real confusing real fast. So, 2 ways to name a plane. You can either use 3 letters of the points that are on there, or you can use a capital cursive letter. However, something that you cannot do is you cannot mix this R in with any of the other letters. For instance, I cannot call it plane C-E-R. Okay? Can't do that because R is not a point. All right, last thing I want to hit real quick. I want to just reinforce this. We talked about the word coplanar, and I can usually tell who's not paying attention in class because they get to homework and they're like, what's coplanar mean? All right, the word is coplanar. Again, that prefix co means together. And we don't have the word plane in there, but planar is kind of the root word plane is kind of in there. All right, so together on the same plane. So I want to do some real quick examples, see if you could identify what's coplanar and what's non-coplanar. So here we've got a diagram, and this is an interesting diagram. It's a 3-dimensional space being represented on a 2-dimensional surface. So we have plane R. You can see the cursive letter there, so plane R. And in that plane we have F, B, W, Y. Line L is in there. And then what this is representing is a line. Imagine my hand's the plane. It's a line coming up through the plane. So this top part up here shows the line coming out the top. Point B is where it intersects. And then that little dashed line shows it going underneath the line. And then point I is on that line. So if you see it, it really makes a lot of sense. But let's talk about what's coplanar and what's not coplanar. So those 4 points, F, B, W, and Y. So F, B, W, and Y, yeah, those are all on plane R. They're coplanar. How about this? F, Y, I, and W. So F and Y, and I is completely off of this plane, but W is on the same plane as F and Y and B, or F and Y. So F, W, and Y are coplanar, but point I is not on the same plane. So we would say that these points are non-coplanar. B, I, and Y. So point B right there, Y, and I. I bet you're thinking, point Y is not on there, it's non-coplanar. But this is a trick question. They are coplanar. Why? Because it only takes 3 points to determine where a plane goes. So points B, Y, and I are on the same plane. It's just not plane R. There's an invisible plane that we don't see in this diagram, but I can draw a plane that contains all 3 of those points. Okay? So anytime you're given 3 points and you're asked, is it coplanar? Yes. If you're given 2 points and asked, are they collinear? Yeah, you can connect those with a line. So any 2 points will always be collinear. Any 3 points will always be coplanar. And I hope that explains the first lesson, our basis for geometry. From here on out, we're just going to be talking about how to connect points, lines, and planes, and make any single shape that we want to in geometry. So hopefully we have a good foundation, and we can get through the rest of the semester with no problem. All right, thanks, guys.